Well, here we are on a Sunday morning, bright and early. Got a couple members of my crew here studying for distribution 1 and distribution 2. These videos, anybody going for distribution, doesn't matter which grade it is, should be going to the basics. This video is more centered on grade 1, grade 2, but if you're going for grade 3, grade 4, this is all basic stuff that you need to know, even as a grade 3, grade 4, in preparation for your exam, your state certification exams. So we're going to start with water quality. Is that the one you have? Yep, water quality. Okay. First question, a water distribution system operator's most important responsibility is to deliver safe and pleasant drinking water to the customers?
Yep.
There you go. That's correct. I have it written on the board quite a bit in our office. Right now it's missing, but the first responsibility of a wastewater operator is to protect the health and safety of our customers. Now, our system is primarily a bedroom community. We've got a very large system, and it's well over 99% residential. We don't have any industry here. We just have restaurants and dentist office. We have a dentist office on every corner out here, don't we?
Mm-hmm.
So, but we have a lot of fast food restaurants, a few dining in restaurants. We have, shopping centers and things like that. A few of them scattered around our system, but primarily our customers are residential. So it's our first responsibility, our main duty is to protect the health and safety of those customers. And that includes not just the people who live here or work here, but the people commuting through here and stopping at fast food restaurant, getting some coffee or breakfast or their soft drinks, things like that. Hang in there, buddy. You'll make it. Oh, you're good. Don't worry about it. Hey, I don't edit things out of the videos because life happens, right? So the other day we were in here, George, and the lights kept going off. And to me, it cracks me. Life is what you make of it, right?
Mm-hmm.
Number 2, what is the most likely cause of red stains on customers' plumbing fixtures? A dusty appearance and or rusty tastes in the water.
It's gonna be your iron concentrates.
You can't answer every question,
Yes,
Brian.
I can. I know it.
We gotta let other people get in there, okay?
All right.
The other two.
We'll have more people on the way too, right? Okay, so George,
That's iron concentration is over 0.3 milligrams per liter in the water.
true, very good. Now I want to make a few points here. First, milligrams per liter. Milligrams per liter is the same as
ppm.
parts per million, ppm. Very good. This brings up appearance and tastes. The main complaint from customers is taste and odors of their water. You got to remember, our customers, they may work at the dentist office as a hygienist or a receptionist somewhere or a cashier at the grocery store. They may not be the mechanic down the street at the shop, right? Might be the fireman right next door. They're experts in what they do. We're experts in what we do. So if the water has a funny odor to it, maybe medicinal, we know that that's more because our source water is groundwater. So we know that because we have several pump sites out in the system, pumping water out of the groundwater, holding it in tanks, we're disinfecting it, and we're sending it out to our customers. And sometimes that water might have a strange taste to it, kind of an alkaline or medicinal taste or odor. And we know that it's because it's groundwater, but our customers don't know that. Our customers don't know that if it has a rusty taste in the water, that it's iron. They're experts in their field We're experts in our field. So it's imperative that we are able to explain these things to our customers, because if your water's not right, if it doesn't look right, if it doesn't taste right, if it doesn't smell right, and you don't know anything about water because you're a cashier at a grocery store, then it's a scary thing. It's a very scary thing, you know, and people are in the right to be worried, their right to be concerned. And we want those customer complaints coming in. We want customer complaints coming in or customer reports. We want to document them, look at them, go out and figure out, hey, is this what's going on? That way it tells us pretty quickly if there's a problem out in our system somewhere that we can fix.
Yep.
Number 3, which of these chemicals contribute to staining of water fixtures? Let's go over here at the end of the table.
A, iron and manganese.
Iron and manganese. Iron and manganese. Iron is the most closely associated with red water stains. Manganese is black stains. And in high concentrations, it can stain clothing. That's something to consider as well. Number 4, what are the 3 responsibilities of any public water supplier?
Providing enough water to meet the total demand of the water system. Providing water that is both safe and potable to the customers, or palatable. Providing that water to the customers when it is needed.
Exactly, perfect. So just so the viewers understand of this video, all these homework assignments, if not right now, pretty soon they'll be available on my website as PDFs, right? So you can purchase the PDFs, you can download them, print them off, do the homework, and then watch the video to get the answers and to hear our comments, the lectures, the questions that come up. So one of my favorite resources to use is what we call the Ragsdale Water Treatment and Distribution Guide. But let's go back to this. Providing enough water to meet the total demands of the system. Total demands of the system is all the water that people regularly use for whatever reason. You know, bathing, cooking, laundry, washing their dishes, filling their pool in their backyard, washing their cars. You know, it includes all these restaurants that we have, grocery stores, things like that. So we want to make sure that we are providing enough water to meet the demands of the system, or customer demands. Providing water that is both safe and palatable to the customers. We were just talking about that. It's got to be safe. It's got to be good quality water. That's why we send somebody out. There's somebody that works here in our utility, and her sole responsibility is to get out in the system every day, 40 hours a week, pulling samples. Pulling samples that go directly to a lab for testing. We get those results. Our primacy agency, the Arizona Department of Environmental Quality, they get the results. We're basically an open book. We want to prove that our water is safe, and we want to know. We legitimately want to know. We want to verify that the water is safe for our customers, because if there's a problem, it's going to get bad really, really fast. People get severely injured or die if there's a problem with the water. And we have so many examples of that in the United States. And that's why the Safe Drinking Water Act was put into place. That's why the EPA was created. That's why we have all these regulations. Providing that water to the customer when it is needed. And what that means is we have to produce the water and store enough that we have in periods of peak demand. And if there's an emergency like a fire, we can still provide enough water when it is needed to the customers that is safe and palatable. Looks good, tastes good, smells good. Okay, let's go to number 5. What are 3 examples of public water usage? George?
Public water usage may be defined as any community services that are required potable water, fire protection, recreation, which swimming pools and golf courses, street maintenance, and rural communities where these services are limited, public water usage may not be.
May not be a consideration.
May not be a consideration.
Perfect. Yep, so public water usage may be defined as any community service that requires potable water. Fire protection. And again, I mean, this is the water that's in our distribution system. So when the firefighters hook up to a fire hydrant, they're using the potable water. And water is expensive to treat. You know, we have a lot of infrastructure we've built. We developed wells, ground storage tank sites, booster pump stations, all the electrical systems that go into that, all the pipes, all the valves, all the fire hydrants, all the ARVs and blow-offs and things like that are out in the system. It's very expensive to build and maintain. But that's the quickest way to get water to a fireman who needs it when they're trying to put out a fire, save somebody's house, right? So it's right there. Recreation, swimming pools, golf courses, all those types of things. Again, we're going back to, we have to have enough water produced and available in storage. That includes the ground storage tanks and all the distribution system piping. You know, we count that water that's already in the pipe as part of our storage system. And those calculations are made when we're developing a new area. Now, where we live here in this area has been one of the fastest growing areas for the last, 5-6 years?
Yeah, it's still going.
And it's still going strong, even though the economy is questionable right now. Interest rates have gone up, you know, and we've expected to see a slowdown, but we haven't experienced that. Their builders are out there. They're still, the developers are developing, the builders are building. We have new customers moving into the system every day. And we commit a lot of resources to that. There's several teams of engineers out there looking at what's growing, how many homes, how many customers are coming into the system. And with that, it brings in the restaurants, the convenience stores, the gas stations. It brings golf courses, things like that use a lot of water, and we have to keep up with that. We have to keep up with that demand. So all this stuff, it seems simple and easy, but there's a lot more it goes a lot deeper than that. It's like an onion, there's several layers to it. It takes a lot of planning, a lot of resources. And we're very fortunate to work for a company, and we're not gonna mention the name, but we're very fortunate to work for a company that puts so many resources to very good use in planning, developing, growing in such a way that we're not gonna have to raise rates for our ratepayers. You know, because that's where we get our funds, so that we can do capital improvement projects, right? It's all part of planning. Street maintenance, and in rural communities, and this is an important note, in rural communities where these services are limited, public water usage may not be a consideration. And we have a few places like that out here, right? This all used to be either desert or farmland. And in some of those farmland areas, we have these communities that have been out there for several years. People kind of started congregating in that area. They're living on acre lots, 2.5 acre lots, 5 acre lots. They have some horses and maybe chickens and things like that. They want to live in a rural setting away from town. Well, now the town is finding them. I mean, we're not quite a town yet. We're still county. We haven't been incorporated yet. And someday that's going to happen. But for now, all this development that we've been seeing over this very large system that we own is now encroaching out there, and it's swallowing up those communities, those people that have been out here for 20, 30 years living in a rural setting with farmland all around them. And we just don't have the infrastructure that reaches out to all of them. A few of them we do, but not all of them. Many of them are on wells or shared wells. Number 6, what chemical can cause red water problems?
Iron and manganese, well known for red water problems and hardness.
Very good. And hardness, just real quick, hardness is the minerals that are in the water. That's a very simple way to explain. Hardness are the minerals that are in the water. Typically calcium carbonate makes up hardness. metals that dissolve easily, or metals or salts that dissolve easily into the water. Number 7, which of the following is not likely to present a water quality issue in a groundwater system?
That'll be turbidity.
Turbidity. Yeah, you know, you would think that you're pulling water from the ground, it's going to be turbid, but the opposite is true. All that sand, rock, the permeable material that we have beneath us that the water moves through is a natural filter. You know, we drill a hole, and out here where we're at, it's several hundred feet, several hundred feet deep. We even go much deeper than the static water level of the groundwater table, right? We go several hundred feet below that, so that when we start to pump, we are not, if you don't go very deep, it's just like you'll run out of water real quick. You don't want that pump to get any air into it.
Yeah, you don't want to cavitate.
So we go we want to go several hundred feet below, if we can, below the static water level of the reservoir, or the groundwater level. And when you activate that pump, you're going to pull the water out, and you're hoping that, or you're expecting that. And we do tests, we do monitoring, we do everything we can to make sure that we're not over pumping that water source. And there's a lot of people involved in that. It's not just the utility, it's also state agencies. You want to make sure that they're managed very, very well, that we're not over pumping that supply and depleting it, because it leads to problems down the road. Lack of water, subsidence is a big issue. They've experienced that in other parts of the country where there's a lot of farming that's been going on for more than 100 years, and they've overpumped their water supply, and the land subsides. In some areas it's huge, 10, 12, 14 feet. So the amazing thing is that groundwater is naturally filtered. We don't get that turbidity that we expect to see, or that we would think that we would see. Surface water is a big problem, because that surface water, rivers, lakes, it's affected by the flora and the fauna. It's affected by the environment. Number 8, which of the following pH values is acidic?
Version 4.5.
4.5, very good. So remember, the pH scale goes from 0 to 14. Right in the middle is 7. 7 is neutral. Anything less than 7 is on the acidic side. Anything greater than 7 is the alkaline side, or the basic. Number 9, water with a pH of 7 is
A neutral.
neutral. Number 10, peak daily consumption may be 2.5 times the daily average.
That's true.
That is true. What that means is there's 2 periods of the day where peak demand occurs. And this is when I say this, I mean this is as typical. So overall, all around the country, you're looking at 5 a.m. to 10 a.m. when people are getting up, getting ready for work, school, whatever they're got to do that day. That's when they're using a lot of water. So the peak demand goes up, a lot of water is being used. Then it drops off around 10 a.m. and you have a period up till about 5 p.m. where there's still usage that's higher than it is at night during the 10 o'clock at night till 5 in the morning. It's still higher than that, but it has dipped down. The second peak period is 5 p.m. to 10 p.m. and peak demand goes up again. So let's talk about peak demand. So peak demand. So what peak demand is, and when we talk about 2.5 times the daily average. So what we do is we have flow meters out in the system. We know exactly how many gallons of water we pumped from a well. You multiply that by the number of wells that we have. We create a spreadsheet that says, okay, here's all our well sites. Here's how much water we've pumped out of the ground. On the other side of that, we have meters at each customer's residence, at each business. Every customer we have, there's a water meter that goes into that customer's residence or business. So we have an accurate count of how much water we've sold or distributed it to our customers. If we take that daily count and divide it by 1,440 minutes per day, for example, we'll get how many gallons per minute we're, on average, through a 24-hour period, is going out to our customers. But that's if, and that number that's an average. That number would be accurate if everybody was using their water at the same time, throughout the day. But because we have these off-peak periods where water is not being used as much by the customers, usage drops down very, very low, especially at night, 10 p.m. to 5 a.m. Water usage drops, it bottoms out around 1 a.m. out here. And there's hardly any water being used comparative to during the day and peak flows. So if we take that average for a 24-hour period, multiply it by 2.5, that would be what we would expect to be our peak flow demand. So if we're using 10,000 gallons a minute every minute of the day, at 2.5 times, you'd be at 25,000 gallons a minute. Okay. Number 11, chemical adsorption is used to remove chemical adsorption.
Organic chemicals.
Organic chemicals, right? Organic chemicals that could be in the water. So there's two words that we need to be familiar with. The first one, adsorption, and that's with a D. Now, one of the chemicals that we use to adsorb organic chemicals that are in the water is GAC, granular activated carbon. There's also PAC, powdered activated carbon. And what is that? Well, it's basically charcoal, right? So, and the reason why is because if you look at a piece of charcoal, if you look at one of these like GAC or PAC, it just looks like a smooth little bead. But if you put it under a microscope, this thing is incredibly jagged. It's got a lot of spikes. It's like if you look at it under a powerful microscope, it looks like the Grand Canyon, but just completely covered in canyons and caves and
everything.
Yeah, so what that means is it has a lot of surface area. So if it was just a smooth little bead, it would have some surface area. But once you add all that stuff to it, all those canyons and crevices and things, it just adds to the surface area. And organic chemicals get stuck to it. As it floats around in the water, it adsorbs all these things, it adds to it. It sticks to the surface. We also want to be familiar with absorption. What is absorption? Well, absorption is like a sponge. If you take a dry sponge and you drop it on a water you've spilled on the table, it's going to absorb it. It's going to take it into itself. It's going to soak it up. Okay, so there's a difference between adsorption and absorption. So let's say you had a question on your exam about granular activated carbon and how it removes organic chemicals from the water. It's a process of adsorption. Beware of absorption in that case. Okay? That's pretty neat. Still learning how to use this interactive whiteboard. It's a lot of fun. Number 11, chemical adsorption. Whoop. We just had that question.
Yeah. There it is.
There it is. There's question 12. High levels of iron and manganese in the drinking water will cause, where are we at, over here?
D, all above.
All the above. Red and black water that stains plumbing fixtures. Red and black water that stains clothing in high concentrations. Cause consumer complaints. It's D, all of the above.
I actually have a question about that.
Sure.
So the manganese causes black particles into the water. Would that be the same kind of, so for instance, when I did my water softener, redid it, I ran it, I allowed it to run through the system and all that, and it was down for a few days, and all of a sudden all my plumbing fixtures started coming out with the black water and all that. Would that be manganese in the system in my house, and then the water softener cleans it out?
Well, the water softener, see, the really great thing about a water softener is the ion exchange process, right? So your water softener is probably filled with sodium pellets?
Correct.
Okay, it's either sodium or potassium. Potassium is more expensive. And I'm just explaining this really quick because, you know, you guys all know I had a heart attack last year, right? So I'm hypertensive. I have to be careful not to let my blood pressure get too high. So my water softener is full of potassium pellets. They're more expensive, but it protects me. You know, you'd rather pay a little extra and have water saturated with potassium rather than sodium when you've had hypertension or heart issues, right? So what that does is the natural characteristic of water is that it will absorb sodium or potassium more effectively than it will other minerals or salts. So when your water has iron, manganese, nitrates, things like that in the water, and you run it through a water softener, the chemical reaction that's occurring there is those minerals are being stripped out and replaced by the sodium or the potassium that you have in your water softener. Because water, just the natural characteristic, it would prefer that. It would prefer sodium over anything else. And if it's potassium, it'll take the potassium up and force everything else out. So that water being discharged out might be black, red, discolored in some way. You know, I had one customer that was asking me about orange water, and we talked about his water softener and if it went through a regen process, if he just did some work on it, and you know, we went through that whole, we had that entire discussion. The reason why the color changed in his water is because of his water softener. So it could be because there's high concentrations of magnesium in your system that needed to be cleaned out. It could be other things though. But what we need to be aware of as operators is that typically red water is iron, black is associated with manganese. Okay, let's go to the next one. 13. What is the most common water complaint?
The objectionable taste and odor.
Very true. Very true. I wish we had the D. Water
Yeah,
is
water
too
is
inexpensive.
Yeah.
But no, and it's not likely that water is too cold, especially out here where we live.
Can't be cold enough.
In the summer, where we had, in just this summer, we had over 30 days of 110 degree plus temperatures as highs. 30 days in a row.
Horrible.
We've had many more days of that where temperatures were over 110 degrees, but we had 30 days in a row. These water meters where our water that we're delivering to our customer is just below grade. So the water lines come up from deeper elevations up to the customer's meter, and that ground is hot. It's baking. So once the water passes through the meter into the customer's home, the water's pretty warm. I mean, last time I used hot water to take a shower this summer was 2.5, 3 months ago.
Yeah, a few months ago.
Yeah, back in like April, maybe.
I think we have that issue at home because our hot water heater is like outside in the elements, and we actually had to put a cover around it to kind of cool
To cool it, shade
that
it.
hot water heater up a little bit. And I mean, it's hot water.
Bumps price?
Yeah, I'll take any help I can get when it comes to technology. I'm 50. I just turned 55 a few months ago, and I feel like I'm doing pretty good until I watch some YouTube video on what your phone could do, and it's like, how am I ever going to remember any of that?
You won't.
So we were just talking about the phone that I'm using. It's a Samsung Galaxy S22 Ultra. And I love using that for video and photos because the quality of the camera is so great. And I really enjoy it. But I have to lean around the camera to shut it off and turn it back on. And it's going to show up in the videos at some point. Number 14, hard water scale is usually caused by
The calcium carbonate.
calcium carbonate A, right?
Yeah.
Okay, I thought you said B.
No.
Calcium carbonate, hard water scale. So that's the scale that builds up on your shower head or your bathroom faucet, your kitchen faucet. Takes a little bit of acidic chemical, lime away, something like that to take it off every once in a while. And you don't get that if your water supplier is if the utility is using surface water and sending that out to their customers after it's been treated. You don't have that problem. You have soft water issues, which that means when you go to take a shower, if you have soft water, you don't use as much soap. With hard water, it's harder to get that lather, that soapy lather, whether you're bathing, washing your hair, even washing dishes. Soft water, you get that, you're able to build up that lather and bathe or wash your dishes, wash your clothes, whatever. It also, after you take a shower, when you step out and dry off, if the water source is hard water, people notice that if the water is hard, they kind of feel like crustier, if that makes any sense. Grittier, yeah. But if it's soft water, you dry off easier and you tend to feel more hydrated. All right, so that's water quality. We're gonna go ahead and move on.